with the Water Environment Federation. I want to welcome each of you to the Specification Standard Guidelines for CIPP, Manholes, and More webcast, sponsored by NASSCO with support from Avanti and Parson Environmental. Before we begin, I would like to quickly review a few logistics. The PDF PowerPoint presentations are now available for downloading at WEF's website. This link was included in the GoToWebinar reminder email sent an hour before the webcast and will be included in the follow-up email sent an hour after the webcast is ended. The follow-up email will also include a link for the webcast Professional Development Hour instructions for those eligible to receive these training credits. There are 2 PDH credits available for this webcast. You will need to complete the evaluation form to receive the PDH certificate. The feedback on this webcast is important and helps identify future webcast topics that are timely and helpful to you. Please follow the PDH instructions and check with your state accreditation agency on how to receive this credit. During this webcast, while you cannot speak directly to the presenters, you will have an opportunity to submit questions by typing your specific question into the GoToWebinar pane that appears on the right-hand side of your computer screen. Today's moderator, Ted DeBoto, will be accumulating questions and directing them to the presenters. We will be recording this webcast. The webcast recording link will be available on the webcast website within 48 hours after the event. If you have any additional questions after the webcast has ended, please email webcast@wef.org. I would like to thank Ted for moderating today's webcast. Ted DeBoto is NASSCO's Executive Director. Ted?
Thanks, Beth. First, I want to thank the sponsors of this webcast, Avanti and Parson Environmental. These companies have been active in NASSCO, been very active in NASSCO in the development of our specification guidelines, and you'll have an opportunity to hear more about them at the end of this webcast. I want to take a few moments to introduce NASSCO, the National Association of Sewer Service Companies. NASSCO's mission for almost 40 years has been to set industry standards for the assessment and rehabilitation of underground infrastructure and to assure the continued acceptance and growth of our trenchless technologies. NASSCO provides the industry with technical references such as the specification guidelines that are going to be discussed today. These documents and many others discussed during this webinar are available for free at NASSCO's website, nassco.org. Today's webinar will be an overview of how the preparation of effective bid specifications are critical to project success. We'll offer guidelines to help you prepare quality specifications for these technologies. Both CIPP and Manhole Rehabilitation Specification Guidelines will be discussed, as well as the importance of performance-based specifications. In addition to CIPP and Manholes, a lot of other free guidelines are available from NASSCO's website, including pipe condition assessment using CCTV, sewer pipe cleaning, pipe bursting of gravity sewer mains, fold and form pipe, and pressure testing and chemical grouting. Our speakers today will be NASSCO's current and former technical directors, Lynn Osborne and Jerry Munchmeyer. Lynn, our current technical director, will provide key components of effective specifications. He'll give a description of the different types of specifications, and finally a walkthrough of a CIPP specification. Jerry, our past technical director, will walk us through a manhole rehabilitation specification from evaluation and assessment to technology selection to specifications and bid documents, and finally to installation and inspection. Now, before we begin, as Beth mentioned, I want to encourage you to ask questions. I'll be monitoring your questions, and we'll have time between the 2 presentations and at the end to address some of your questions. Our first speaker is Lynn Osborne. Lynn's the owner of LEO Consulting, an engineering consulting firm specializing in the trenchless rehabilitation of pipelines. Lynn has over 40 years of experience in the water and sewer industry, including 9 years as a project manager for a multidisciplinary civil engineering firm and 31 years in engineering with a large technology provider and contractor primarily in the trenchless technology industry. Lynn's the current technical director of NASSCO, and he holds a bachelor's and master's degree in civil engineering. He resides in Garden Prairie, Missouri. Lynn?
Thank you, Ted. Okay. My slides are not moving.
Double click, Lynn. There we go.
Okay. Thank you, Ted, for that introduction. And what we're going to do is look at performance specifications for cured-in-place pipe. And as Ted said, there is a full cured-in-place pipe performance specification on the NASSCO website. And this presentation is essentially going to be a walk through that presentation. So if you don't get enough information on these slides, you can always go to the NASSCO website and download the entire specification. First, we're going to talk about effective specifications, and that's, of course, what we want. That is the objective, to have effective specifications, and these are critical to project success. Project success includes the product selection for the best solution and at the best cost. We want the most cost-effective product for the project. It includes a definition of project goals and requirements. It includes the construction means and methods as defined by the contractor. And we're going to talk a lot about this as a performance specification, with the contractor providing the means and methods in a document called the performance work statement as a submittal. And then again, the products as provided by the manufacturers need to be installed in accordance to the product manufacturer. We're going to hit on that several times throughout the presentation. Quality will be confirmed through inspection and testing, and product design life and service life verified through a warranty inspection. Okay, if I can get the clicker to work right here. First, we're going to talk about prescriptive specifications. We're going to discuss 2 or 3 different types of specifications. In the prescriptive specification, basically the design engineer tells the contractor how to build the project. The means and methods are as defined by the engineer and implemented by the contractor. So if the means and methods are properly executed, but the results are not achieved, who is responsible? Well, there is case law available to review that indicates the design engineer can be responsible in those situations. Performance specifications are on the other end of the spectrum. These require that the contractor use experience and innovative means to deliver the product, a specified product, at a defined level of quality as specified by the engineer. This requires that the contractor, not the engineer, define the means and methods by submitting a detailed performance work statement document as a submittal. Now, in this case, if the means and methods are not properly executed, who is responsible? Well, of course, it's the contractor. Now, there are also combination specifications, and these are quite common in the industry. This is where the contractor is required to define means and methods, but the engineer does also. So in this case, who is responsible if the means and methods are all followed, but the results are unacceptable? Well, that can be questionable. The contractor certainly has responsibility, but the engineer might also. So that can raise questions. Okay, we're going to get into the specifications now. There are 3 parts. There is a general part, products part, and an installation part. First, we're going to look at the general, and there are several different categories you see there on your screen. And we're going to talk briefly about each one of those, but in particular, 1.3 and 1.4, the performance work statement and product submittals. Minimum requirements for the rehabilitation of sanitary sewers by CIPP. That's the general idea. And this is through the installation of a flexible resin-impregnated tube that must extend the full length of the original pipe And the objective is to provide a structurally sound, jointless, watertight, new pipe within a pipe. In performing this and installing this product, these activities, nor should the finished product cause any adverse effect to the owner's processes or facilities. None of these activities should cause materials to be discharged down the sewer that might clog a sewer or flow into the treatment plant. The CIPP installation should cause the least possible obstruction and inconvenience to the community. Not quite out of sight, out of mind, but that would be the objective. The specifications include a description of the work and product delivery. This is simply a detailed description of the work required, everything that's included in the installation. What is to be delivered by the contractor, including dimensional aspects of the cured-in-place pipe. Length, for example. The CIPP must be continuous from manhole to manhole. It must be the proper diameter to result in a proper fit in the hose pipe and have a good visual appearance. The expected or anticipated product life should be spelled out, in addition to other parameters such as long-term corrosion resistance, creep retention, and so on. Most specifications include a section on references. These are references to other third-party type documents that have information pertinent to the project, ASTM, NASSCO, AWWA, so on. Know what are in these documents, know the information that is included, and it should be pertinent to the project. If there's nothing in a reference document pertinent to this document, it shouldn't be there. As far as specific reference document requirements that are pertinent to this particular project, these can be handled by one of two different methods. One can be spelled out by words, just write it out, what the requirement is, or could be a reference to a specific section in the document. For example, if you're wanting to specify sampling techniques for cured-in-place pipe, you could spell it out in paragraph form, or you could refer to paragraph 8 of ASTM F1216. Next is the performance work statement. This is a very important part of the contractor's submittals in a performance specification. This will be abbreviated as the PWS quite often and following throughout this presentation. But up front is a statement of product conformance to the contract documents. This needs to be set straight up front because you may have been involved in projects where you're well into the submittal process, well into the project, and it's determined that the product that's being provided does not meet the specs. Well, you need to get over that hurdle right up front. Other important provisions include, of course, installation to the manufacturer's recommended standards. And as shown in C, a detailed installation plan. That is the crux of the performance work statement, how the product is installed. Should also include a statement of contractor experience and lead personnel to include resumes. The contractor should have the experience to install, a project of this size, and it should also have the lead personnel on the job that have had experience with this type of project. This is where the CIPP wall thickness is, the design for that is shown. That may be by a third-party engineer. It may be stamped and sealed, but it's included in the performance work statement. And then there are several other items. The last one listed there is the manufacturer recommended repair and replacement procedures. We're going to get into that in a little more detail, but sometimes defects need to be repaired, and that has to be spelled out in the performance work statement. Product submittals. These should include the major components of the cured-in-place pipe, the fabric tube, and the resin, For each of these, manufacturer's information, cut sheets, specifications, test results should be submitted in a product submittal. On the right there, upper right, you see a photograph of a standard CIPP tube with layers of polyester felt, and on the bottom photograph shows a tube being wet out with resin in a manufacturing setting and for a manufacturing wet out vacuum impregnation. Manufacturer shipping, storage, and handling recommendations need to be included. We need to protect these materials while they're being shipped, stored, and handled. Safety data sheets. And then very important, the tube wet out, installation, and cure method in accordance with manufacturer's recommendations. And the last bullet you will see several times because it's a very important step in CIPP installation, and that is the manufacturer's recommended cure schedule. Very important that that is always followed. The contractor will need to submit a safety plan. Contractor should conform to all work safety requirements of the pertinent agencies, including OSHA. This should most certainly also include confined space entry techniques. You see bottom right there, you see an artist's conception of some training in confined space entry. Very, very important in our business. But this safety plan would include a description of the daily safety program and all emergency procedures. And then, of course, all work should be conducted in accordance with the contractor's safety plan. There should also be a quality control plan. At a minimum, this should include a discussion of the proposed quality controls that have been specified. The specification should lay out the proposed quality controls. There should be defined responsibilities for assuring that this happens. These should be assigned to specific contractor personnel, and that should be laid out in the submittal in the quality control plan. This would include procedures for product sampling and testing. There should be reviews between the contractor and the owner, quality reviews at a regular basis. Those could be a part of the regular job site meetings, but it needs to happen. We need to remember that cured-in-place pipe is manufactured remotely, typically underground, typically in a very harsh environment, often a sewer. Thus, everything is not always perfect. Some repair procedures need to be defined by the contractor. These recommendations include 3 different categories. The first category are those issues that really won't affect the operation or longevity of the product. So they're okay, they can be left in place, but we need to know up front what those are. The second category are the repairable defects. These are defects that will be okay if repaired properly. And those repair details need to be laid out step by step in this submittal. And then there are the defects that are not repairable. These need to be listed also, and procedures for removal and replacement of these defects. For example, on the right, if you've never seen a cured-in-place pipe lift, that is a cured-in-place pipe lift. It's usually at the bottom of the pipe. It's simply a portion of the tube that was not completely cured when the inversion and curing pressure was removed, and external pressure, typically from groundwater, simply lifts a part of the tube up. That needs to be repaired or removed. There should be as-built documents to include as-built drawings that include simply the identification of the work that's completed by the contractor. This should include pre- and post-inspection documentation, and these drawings should be on the job site at all times for 2 reasons. One, they should be updated on a regular basis, so they should be available. And 2, they should be available for the owner and inspector review, as necessary. Warranty provisions, the materials used for the project should be certified for the specified purpose, and then in turn the contractor should want not only the material but also the installation for a period as specified in the contract documents. On any work that's been completed that was considered to have a defect but was okay and left that way, or has been repaired, the contractor can warrant this work for an extended period, often called an extended warranty. This should also be defined in the specifications. And then after a period of time following completion of the project, the owner should select certain line segments to be inspected as a warranty inspection. Okay, that takes care of Part 1 general. Next, we're going to look at Part 2 products, and this includes the materials, the tube and the resin, and the structural requirements and minimum physical requirements, or how these are specified. First of all, materials. The CIPP system must meet certain qualifications to be suitable. One of these is chemical resistance. That should be specified. It should be chemically resistant to sewage or whatever the material in the pipe flow is. All shipped materials should be accompanied by test reports that are certified that the material conforms to a specified ASTM standards. And then again, the material should be shipped, stored, and handled in a manner consistent with the CIPP manufacturer systems recommendations. And why is that? Well, we want to prevent damage. If they're shipped, handled, stored properly, damage will be held to a minimum. This is more in line with the tube. It can also apply to the resin. But for the tube, damage can be gouging or abrasion, cutting, puncturing, UV light degradation. There can be a number of ways to damage these tubes. Any on-site location should be approved by the owner. Why? Well, the owner needs to determine if the materials are being stored in accordance with the manufacturer's recommendations. And if there are damaged materials, they should be promptly repaired or removed. The photograph here shows a cured-in-place job site. This is a large job with a tube. You see a tube on the flatbed trailer there, and immediately to the left of the tube is a portion of a 5,000-gallon resin tanker. These are materials that have been shipped to a job site. The tent contains a wet-out conveyor. That's where the vacuum impregnation will take place. This tube and resin combination is much too large to transport down a highway, so everything happens on the job site. But this is where observations of these materials, inspections can take place. The fabric tube itself can be a non-woven felt fabric. It can be a felt fiberglass. It can be just fiberglass, or it can be a carbon fiber felt combination. It can be a number of things, but should meet the requirements of ASTM F1216 for inverted cured-in-place pipe, F1743 for pull-in cured-in-place pipe, or F2019 for pull-in light cure cured-in-place pipe. The D5813 is the material specification for all cured-in-place pipe. Once the resin is added and the product is cured, it should exceed the design thickness. It should fit tightly around the internal circumference of the original pipe. And the contractor should verify in the field the length from manhole to manhole prior to ordering or prior to the wet out of the tube. Very important, this is a quality issue because it happens periodically where the shot comes up short, and that can ruin your entire day. In addition, the contractor should measure the inside diameter of the existing pipelines prior to ordering the tube or wet out of the tube. Same thing, it happens not really often, but it does happen where An 8-inch tube will be installed in a 12-inch pipe, or a 12-inch tube will be installed in a 10-inch pipe. It does happen. It's a quality issue. This can be prevented by proper measurements and detailing those measurements, sending them back to the ordering and wet out facility. The fabric tube should include no intermediate layers that may cause delamination. These are typically thermoplastic coated layers that don't bond well, and we don't want delamination. There should be no dry or unsaturated layers after wet out. If so, that's a quality problem. And the outside layer of the tube should be marked at least every 5 feet with the name of the manufacturer of the CIPP system or the manufacturing lot and the production footage. It can be marked every 3 feet. Some people mark every meter, but every 5 feet at a minimum. The resin is a corrosion-resistant polyester or vinyl ester resin and catalyst, or an epoxy and hardener system, whatever is specified. And obviously, when properly cured, this CIPP should meet appropriate ASTM requirements and the physical properties used in thickness design. And this is an important point. The specifications, and we'll see a typical materials physical property spec here in a minute, but there's generally a minimum specified, and then the design is completed using that minimum or possibly using a higher physical property resin. Whichever physical property is used should be the one that is met when the product is installed and tested. So the resin should produce a cured-in-place pipe which will comply with or exceed the structural and chemical requirements of the specification. Resin quantity should be verified. The manufacturer can tell you, for the particular size and thickness being wet out, how many pounds a foot should be vacuum impregnated into the tube, or should be impregnated into the tube. So that needs to be checked at wet out. If it doesn't have the right amount of resin, it simply won't be as high a quality as if it's wet out properly. Okay, we talked about this cured-in-place pipe meeting or exceeding the minimum physical properties specified or those used for design. We are still designing with ASTM F1216, have been doing so for over 25 years now. There are other design methodologies in the works that may be a year or two out, but for now it's ASTM F1216. This design assumes no bonding to the original pipe wall. And for unreinforced CIPP, those products that have no reinforcing fibers, the long-term creep retention factor is typically set at 50% of the initial design flexural modulus. And this is as tested by ASTM D790. This is the way cured-in-place pipe has been designed for decades for unreinforced cured-in-place pipe. And if it's designed properly and installed properly, structural failures are just essentially non-existent. There are failures, but that simply means it typically wasn't designed or installed properly. This value should be used unless the contractor submits long-term test data in accordance with ASTM D2990 to verify a higher value. And also for reinforced products. A reinforced laminate may have a much higher retention. There on the right you see a test set up for ASTM D2990. You see the little test bars of the material on a test jig with weights hung from each one of those and dial gauges where the deflection is measured at set points over 10,000 hours, and that can be projected to 50 or 100 years to determine the retention factor at those time periods. These are the minimum physical properties basically out of ASTM F1216. That third column over shows the value specified in ASTM for flexural modulus, 250,000 psi. That is often what is specified in CIP specifications. But the critical word here is minimum. The last column to the right, the design value for the contractor may use a higher value. For example, enhanced resins that are used throughout the industry, typical flexural modulus values of 400 to 450,000 psi are used. So if that's what the design is completed with, when the product is sampled in the field and tested, that is the value that should be met. Now, if it's a reinforced product, such as shown in the photograph at the lower right, that's a carbon reinforced CIPP laminate. These reinforced laminates could have flexural modulus in the range of 1 million or 2 million. So if that's the design value, that's the property that should be met when the test results come in. Down below, you see several parameters that are typically specified. One is factor of safety. 2 is very common in the industry. If it's a larger size pipe that's been entered and inspected and maybe soil borings have been bored around the pipe, all the design parameters are well known. That factor of safety can be dropped to 1.5, but that's simply an engineering decision. The ovality, 2%, is a very common default value, or as measured, it may be higher than that. Constrained soil modulus in accordance with AASHTO or AWWA references. Soil load, often soil information is at a minimum on these jobs. So commonly 120 pounds per cubic foot is used. That's a very heavy soil, but it's also very conservative. And if you don't have any other information available, it's a good value to use. Okay, that concludes part 2. We're going to take a look now at part 3, installation. Construction requirements. First off, the contractor should furnish all labor and equipment necessary to complete the work. It sounds simple enough, but there have been jobs where arguments occur over who should supply a certain piece of equipment. So that should be taken care of in the specifications. Contractor obviously should furnish a traffic control plan, should clean the pipe, remove all debris that will interfere with the installation, provide bypassing. On the lower right there, you see some discharge lines from a very extensive bypass system that was set up for a cured-in-place job. Perform post-cleaning video inspections of the pipelines. Should remove line obstructions. Could be protruding taps, severely offset joints, whatever it is. Contractor should confirm the locations of all branch service connections. Now, typically, only the service connections deemed active by the owner should be reopened. So it's a partnership here. The contractor and owner have to work together on these active services. Installation of CIPP, there on the right, you see an installation machine for air inverting small diameter cured-in-place pipe. But again, very important, the CIPP should be installed and cured in accordance with the manufacturer specifications as described in the performance work statement. And also should be installed in accordance with all applicable ASTM standards. Prior to installation, we want to keep track of this cure. It's a very important part of the procedure. But prior to the installation, the remote temperature sensor should be placed inside the hose pipe for the purpose of monitoring temperatures during the cure cycle. Interface temperatures are typically required. This is a location between the tube and the hose pipe at the 6 o'clock position, and these should be monitored and logged during cure. Each sensor should record both the maximum and specified cool down temperature. Should be able to cover the entire temperature range. Now, if it's a UV cured CIPP, all light trained sensor readings should provide output documenting the cure along the entire length. So we have different types of cure. We have heat cure and UV cure. The photograph shows a medium-sized cured-in-place pipe inverted by air, and it currently is being cured by steam. You can see the water vapor trailing out of the top of the tube. Cool down, of course, cool down should be in accordance with the manufacturer's recommendations. You see on the screen 2 ways to monitor temperatures during a cured-in-place pipe cure. On the right is a method that has been used essentially since the start of the installations for cured-in-place pipe. It's a digital readout. It's attached to a wire that runs down to a thermocouple that's placed in the interface between the tube and the pipe. And a worker will walk by with a clipboard every 15 or 20 minutes, half hour, whatever is specified, and record the temperature. At the bottom is a method that's been used for a few years very successfully, where a fiber optic cable is installed prior to the installation of the cured-in-place pipe. And once the cure starts, the temperature can be read at any location in the pipe at any time by anybody that has a computer or a smartphone. So it's a very, very powerful tool and is being used quite a bit in the industry. So whatever you want needs to be specified, either one. So what we're after is the installed CIPP should be continuous over the entire line section and should be free from significant, keyword, significant visual defects, such as foreign inclusions, things that got stuck in the pipe wall, dry spots, pinholes, major wrinkles, and delamination. You see on the right there a photograph of a completed culvert CIPP. You're looking clear through this one from end to end. And at about 9 o'clock and maybe 4 o'clock, you can see some minor defects, minor wrinkling, which are really nothing. This is very common in cured-in-place pipe. Very minor defects like this are to be expected and are not a problem. So that would fall into that first category we talked about a few slides ago. The CIPP should be free of leakage, either out of the cured-in-place pipe into the ground, or the groundwater shouldn't be leaking in. And any defect which will affect the structural integrity or the longevity of the CIPP should be repaired, and the method of repair would be in accordance with those procedures previously submitted. The beginning and the end of the CIPP should be sealed, and if specified, any service connections that have been opened and are leaking water, groundwater that's gotten between the CIPP and the hose pipe and then finding its way into the sewer, those should be sealed. And if the wall of the CIPP leaks, that should also be repaired. Next, we're going to talk about manhole connections and reconnections of existing services. For a manhole connection, hydrophilic rubber seal should be applied before the CIPP is installed, and then the cured-in-place pipe is installed over this. Being hydrophilic, when it gets wet, it expands and performs as a gasket between the cured-in-place pipe and the host sewer, and it works quite well. So that takes care of the manholes. You got to do it before you install the CIPP because it gets difficult afterwards. Again, it's the contractor's responsibility to make sure all active service connections are reconnected as reviewed by the owner. Now, for the service connections, the opening should be at least 90% of the connection opening, and the invert of the connection, cup connection, should be cut flush with the invert of the service line entering the main line. The upper photograph you see is either a very poor service lateral cut. You know, it's irregular, it's got jagged edges. It's also not flush at the bottom with the lateral line, thus this is a plug waiting to happen. The cut at the bottom is a good service lateral cut. The opening should not be more than 100% of the service connection opening. And if it is overcut, the contractor should install a CIPP type repair, much the same as installed as when laterals are rehabilitated from the main line. Or it could be grouted. There are several different ways to do that. When cutting lateral connections, coupons of the material fall out into the sewer. These should be collected and disposed of, typically collected at the downstream manhole. Testing, very important part of the process for quality control. Physical properties should be verified through field sampling and testing in accordance with all applicable ASTM standards. The requirements for this testing and the payment should be clearly defined in the specifications. Who absorbs the cost for collecting the samples, who pays for testing the samples, all should be laid out. Each line segment should be sampled, and the samples should be prepared in accordance with ASTM F1216. And you see the two accepted methods in ASTM F1216 in the photographs at the right. The upper is a manhole sample where a pipe of like size, that happens to be a PVC pipe, is placed in the manhole, and the CIPP is inverted or pulled through that and cured, and then that is cut out and becomes the sample for thickness testing and physical properties. That works up to 18-inch. Greater than 18-inch, it gets very difficult and dangerous to try to collect manhole samples, for example, in a 36 or a 48-inch pipe. So felt of the same configuration that's in the tube is wet out and placed between two metal plates, and it's cured along with the cured in place pipe. And that particular sample is then used for testing. A chain of custody should be maintained by the owner's representative. If the physical properties tested do not meet the physical or thickness requirements, minimum physical or thickness requirements, the CIPP should be repaired, relined, or replaced unless the actual physical properties and the thickness of the sample tested meet the design requirements of the contract. So what happens here, if there's one line segment, the physical properties have come in low, what will happen in this case would be the contractor or the designer would use the actual physical properties and the design parameters from that particular line segment. Depth, groundwater, is there a traffic load, diameter, ovality, everything, and run a design and obtain a thickness. If that thickness is less than the tested thickness, it's good. If it's not, something needs to be done. Chemical resistance is a qualification test where CIPP samples of the tube and resin used proposed for the actual project construction are tested. This is typically tested by the resin manufacturers and is available from the resin manufacturers. And a manufacturer certification can be submitted verifying the chemical resistance of that felt and resin combination. The installed CIPP thickness should be measured for each line installed, and there should be a tolerance. Often in the industry, I see -5 +10 tolerance. If the engineer desires to measure thickness in entry size piping, remember for that size piping we don't have the manhole sample to measure thickness. And there's a desire to measure thickness. About the only way to do that is to remove a sample from the pipe itself. Final acceptance, all sample testing and repairs to be installed to the installed CIPP should be completed before acceptance. And then these test results and repairs should meet the requirements of the specifications and be written and be documented in written form. The contractor should perform a detailed CCTV inspection after installation and reconnection of the service connections. The collected data during this inspection should note the inspection date, the location of all reconnected service connections, as well as any other defects in the CIPP. Now, this post-installation inspection documentation should be submitted within a reasonable amount of time, for example, 10 working days. And if it's not, the owner may include provisions in the specifications to suspend further work until the documentation is submitted. Prior to conducting the final CCTV, the contractor should thoroughly clean the new cured-in-place pipe. There should be minimal sewage flow in the line during this inspection. If the pipe has a significant flow, bypass pumping or plugging is required. If there's standing water, like in bellies, that should be removed so you can get a good look at that area. Often a jet head is pulled in front of the camera to move the water out of those low areas. And where leakage is observed through the wall during this inspection, really there are two options. The engineer may require the contractor to repair the leakage, or the contractor may institute additional testing that will verify that that leakage does not exceed the acceptable specified tolerances. Okay, we've got several pages of typical bid items. I'm not going to read these or discuss them all. There's just too much, but you've got these. We have mobilization, the pre-line inspection, die testing of service connections. Part repairs, I will mention. Part repairs, I'm talking about, in this case, it would be a dig type point repair. Needs to be spelled out very efficiently on how these are going to be paid, because we're protecting two different groups here. We're protecting the owner from overcharges and the contractor from excessive costs. And either way, it can go either way, so it should be laid out in the bid items. Pipe cleaning and heavy pipe cleaning, inspector training. May want to include a bid item to train the inspectors for the CIPP inspection on this project. NASSCO does offer the inspectors training certification program. CIPP installation, traffic control, and sewage bypass. Two different duties that may be performed by subcontractors. Payment needs to be spelled out. Service reconnections and service connection sealing, in addition to manhole wall interface sealing. Often that is included in the installation of the CIPP, but it can be included as a specific pay item. And then finally, post-construction CCTV and a reserve for testing. In summary, I think this first bullet summarizes where we're trying to go with these performance specifications. But these are the directions and guidance for contractor installation and owner measurement, inspection, testing, and documentation. The intent of the contract needs to be clearly defined, and the products to be provided by the contractor should be defined as to quantity and quality. Now, how these products go in the ground, how they're installed, that's up to the contractor as defined in the performance work statement. But the quantity and the quality should be specified. Measurement, inspection, testing, and documentation requirements should be clearly defined, as well as all payment provisions to include measurement, inspection, and testing. So that is the end of my presentation. I think we have questions next.
Yeah, thanks, Lynn. We have been getting quite a few questions coming in, so I'm going to start at the top, and we'll just take a few minutes, and then we'll take whatever time we can at the end to answer the rest of them. Just want to mention that on the NASSCO homepage, we do have frequently asked questions specific to cured-in-place pipe. So there's some of those, and as a point of fact, when we get a chance to get all these questions together and get them answered, we'd like to supplement that with your questions. So first, I'll start off kind of a simple question. Do you recommend air testing for CIPP installations?
I'm glad you started off with an easy one. No, that is not an easy question. Pressure testing or leakage testing can be difficult with cured-in-place pipe. Air testing can be difficult because, number one, you can only do it on small pipes. Obviously, you can't do it on large pipes. Sometimes it's difficult to seal the plugs, and you can get some leakage because the pipe may not be around. So there are a lot of challenges. However, air testing does occur, and it does occur successfully. So I would say for small diameter cured-in-place pipe, air testing can be used, yes.
Okay. Another question was, in reviewing references, is there a rule of thumb for what ranges of pipe sizes are considered similar? For example, installing 18-inch CIPP, is that significantly different than 24-inch or 36-inch?
That's a good question. I would say 8-inch through 12-inch, pretty similar, maybe on up to 15-inch. 18 through 24, maybe up to 30, kind of the medium-size range. And then once you get much above 48-inch, you're into the large diameter. But above 72, I would call the extra large that sometimes require special installation requirements.
Lynn, is there a list of commonly encountered defects for CIPP?
I don't know of such a list. I know the installers have lists that they've submitted when that is required as a submittal, but I don't know a public list. Maybe that's something we could put together for NASSCO, unless Jerry knows of a public list.
So actually, I can take a stab at that one. The PACP program actually has what we call lining features that we train, and that's in the manual. There's 13 different lining features. For example, delamination, overcut services, undercut services, and things like that. One of the issues with that is that they don't really talk to the severity. There could be different things going on for the same type of lining feature defined in PACP, even though it looks the same. There could be different things going on or different levels of severity. But yeah, that's the list I would think of. Jerry, do you know of a list?
No, there really is no list. I look at defects as Lynn mentioned, the three categories. There may be a whole slew of category 1, strictly cosmetic. We'll consistently come up with new ones that I'm not sure how the contractors create them out there, but they do. And then there's the ones that require repair and those that just aren't acceptable. And there is no list, as far as I know, which specifically defines each one at this point.
Okay. Another question, moving along, try to get as many of these as we can. Is there a typical warranty for CIPP? You mentioned
the typical.
Yeah. Okay.
Yeah, for the entire project, the typical contractor's warranty is 1 year. And that's typically what most CIPP specifications have. Sometimes I've seen 3 years. Once you get to 5 years, it starts getting very difficult for companies, especially public companies, to bond those. But the typical contractor's warranty is 1 year.
Okay. And another question on minimum wall thickness. Are there standard calculations? Can a performance spec just call out minimum strength properties and leave it up to the contractor? Can you comment on minimum wall thickness?
Absolutely. That's what we would recommend, is to specify minimum physical properties and specifying as minimum that higher physical properties can be used. Let the contractor or the contractor's engineer do the design and submit those to the performance work statement for approval by the engineer.
Okay. And I'll throw the last one out there. Are there other methods of sealing at manhole and service connections?
Right now, the best method at manholes are the hydrophilic rubber grout or the hydrophilic rubber gaskets. If you don't use those before and you want to seal after the fact, after installation, grouting is about the only way that I'm aware of. As far as lateral connections, there are the cured in place top hats and full wrap connection sealing methods. There are also grout, several effective grout methods that can be used.
Okay. Okay, and when do you use vinyl ester versus epoxy?
Well, for the CIPP contractor, it's very simple. They use whatever's specified, but for the specifier, the vinyl ester is often used, number one, for pressure pipes, sewage force mains, or if there are chemical requirements that are required for corrosion, like in an industrial setting. There may be other requirements in a city where they do dosing with chemicals in sewers that require vinyl ester resin. But if it is standard sewer, polyester resins will handle all corrosion requirements. If there are higher corrosion requirements, especially on the high pH scale, typically go to vinyl ester or for pressure pipes.
Okay, I'm going to try to throw one more in here. How is watertight defined, and does ASTM 1216 have allowance for infiltration?
ASTM F1216 is a little bit ambiguous. It does have a testing allowance that everybody recognizes that apparatus for testing leaks. Plugs can leak, valves can leak, so there is a testing allowance, so many gallons per inch diameter per mile per day. There is also a statement in the ASTM that there should be no leakage. So it's a little bit ambiguous, but there is a testing allowance.
Okay, we have an awful lot of questions. I was trying to get as many in as I could, and we're going to have time after we're done for questions. Again, if we don't get to your questions, we do have the FAQ on the NASSCO homepage, and at some point we'll be taking these questions and trying to get answers for all or most of them and updating that FAQ as we go along. So I'm afraid we're going to have to keep moving forward, though. And we'll move forward with Jerry Munchmeyer. Jerry's a registered professional engineer with over 50 years of experience. He's been instrumental in bringing the cured-in-place pipe application to the United States over the past 35 years. And his professional career has been dedicated to the development, support, and promotion of trenchless pipeline renewal technologies. Jerry's been a leader in teaching, training, and certifying trenchless professionals, and has written numerous articles, papers, and specifications for the benefit of the renewal industry. He's chaired numerous industry organizations and most recently served as technical director of NASSCO. He has been inducted into the Select Society of Sanitary Sewer Sleuths, the 5S Society, and was selected in 2014 as Trenchless Technologies Person of the Year. Jerry?
Thank you, Ted. Appreciate that. I am going to talk a little bit about more the manhole side. We've talked about the cured-in-place, which is probably one of the first guidelines we put together. Then we put the manhole specification guidelines, and these are guidelines, by the way. They're not bid specifications. We encourage anybody using these specifications to think out their own projects for the specifics, but use these as a guideline to maybe prompt some thought processes as you go through. What I'd like to do with the manhole side of this presentation is not get redundant to what Lynn just went through. He went through all the details. The specifications are set up similar in terms of inspection, quality controls, and whatnot. But I'd like to start off a little bit with the kind of what's important with the manholes. One, manhole rehabilitation doesn't involve one technology. It involves multiple technologies. You have, as a general rule, you have 7 different components. You have anything from the casting to the cone, to the bench, to the invert, to a variety of different components of the manhole. And each one of these have different rehabilitation approaches, and in many cases, a project may include all or none of them, or, well, if there's none, obviously there's no project, but they may include one or more of these technologies. So what I like to do is go through a little bit on the approach. The rehabilitation can be pretty complicated because of all of these different products, and every salesman out there will tell you theirs is the best. Well, I'm here to tell you they're all good products. They just have a right place where they should be applied. Some more in more places, some in less places. So selecting the product can at times be confusing. There are many methods. Each method, however, needs to be evaluated to determine its applicability to the solution that you're trying to create, and then to develop the best approach towards the rehabilitation and maybe what family of products best meet the solution. It might be a build-back solution first, and then a top coating solution. It may be a combination of things. So we need to look at that. It takes a thorough evaluation of the manhole and the condition of the manhole to be rehabilitated. As we said, NASSCO has created a number of different programs. One of them is the Manhole Assessment Certification Program, which is basically a continuation of the Pipeline Assessment Certification Program. And it goes into basically developing uniform codes and uniform defects identification for manhole structures. So once that is evaluated, then we can really go to the next step and start looking at different products. We have to define what are the defects, and the defects will vary depending on the component in the manhole. If it's the casting, it's one approach. If it's the wall, it's another approach, and so on. But we can still categorize manhole defects into 4 general categories. We could say they're structural, which the manhole is deteriorating, it's got some structural issues. It could be operational, where maybe it's some part of the system isn't functioning properly, or it could be maintenance, where it just hasn't been cleaned in 100 years. And I've got a photo of one of my presentations where they take out a brute ball the size of the manhole, comes out of the manhole, so that obviously has never been addressed. Those things happen, and those things we run across. Now, construction features could be anything where the manhole is built in a specific configuration to accommodate the geographic conditions and things of that nature. And so all of the things need to be looked at as we select a rehabilitation technologies. So we can classify them into different categories. We can say grouting. Grouting, great technology, been around for many, many years. It's a way of stopping leakage. We can go cementitious products. They are used typically for structural rebuilding. You can put fairly thick wall thicknesses on the manhole and so on. Polymer coatings typically are your plastics now that really give you some much higher level of corrosion protection. Your cured in place liners, which is a combination of a fabric tube, much like what Lynn talked about for sewers. It's a fabric tube that's impregnated with a resin and then installed. Very, very, very stout system for rehabilitating a manhole. There's panel liners, there's mechanical seals, there's bench and channel inserts, and we'll talk about some of those as we go through. So let's look at some of the defects that we might find in the manhole. Well, once we define the defects, then does the technology provide the desired long-term solution? And a long-term solution is a critical term. It's not, will it just solve the problem for 6 months or a year, but I think most owners are looking for an extended term. Whether it's 50 years or 20 years or 30 years, it depends on the product and the manufacturer. Does the technology go beyond solving the immediate? Yeah, I mean, there are products that do not only structural but leak control and corrosion protection, where some may do one of those three. So obviously, if you're only trying to solve one issue, then maybe selecting a product that solves all three problems is an overkill. But then again, there may be value to that, so that has to be evaluated. Does the technology ensure compatibility with other materials? The classic really comes to mind years ago when a contractor went to Home Depot and bought a repair product, quick-set cement, applied it to his manholes before he put the top coating on, and everything failed. Well, the two materials weren't compatible. So the compatibility of materials is very, very important, particularly when using multiple products and applying a product that's the bond onto another product. Is it suitable for site conditions? Can you get to the manholes? Can the equipment get there? Which product fits best the site conditions? We want to always look at proven installation techniques. We want to look at things that have been around for a while, not something that somebody just invented. If somebody just invented it, we want to give them an opportunity, but they need to prove their product over time. Contractor capabilities, again, it's very similar to lining. We want to make sure the contractor has experience. We want to make sure that his crew has experience. And so those are kinds of things we want to look at in selecting the technology. The technology verification, many products and technologies and variations available. So we've got whether you're in the polymer family or cement family, you've got Portland cement, you've got calcium aluminate cement, you've got gel polymer materials. The industry has grown significantly. So you need to contact the product manufacturer to discuss and verify the product capabilities, make sure you get a good history on the product in order to verify that the technology will work. Require the supporting documentation and third-party testing. And remember, it's only once it's been tested by a third party or an unbiased entity that it really becomes a commercial product. Multiple technologies may be required, and that's very, very common, where a manhole needs to be built back, the structure needs to be built back, and then it needs a top coating to prevent corrosion. So multiple technologies are not uncommonly used in the industry. Some of the products out there, the family of products you want to take a look at, you've got chemical grouting, a great product for solving leakage, getting rid of I&I out of a manhole. Cementitious manhole restoration, as I said, there's multiple different technologies out there. They're usually used for building back. They're used for, let's say, rebuilding an old brick manhole where the mortar has failed over years. I mean, we've got brick manholes in the ground over 100 years old, and in many cases the brick is fine, but the mortar has deteriorated. Well, it's a way of replacing that mortar. Corrosion is not an issue, so it's a great choice for that type of application. As a matter of fact, probably on an industry basis, 50 to 75% of manholes are still usually rehabilitated using a cementitious type of product because there's no corrosion. And once there's corrosion, then of course the other products prevail. The polymers, that's the products that are used when we get into higher levels of corrosion. And quite frankly, we may see more of this usage in the future because as we continue taking clean water out of a system because of EPA mandates and SSOs and whatnot, we're going to get a higher concentration of corrosion. So polymers may become more popular even more so than they are now. They may become more popular in the future. Again, compatibility of materials is very important. It is important in determining compatibility to get something in writing from each of the manufacturers. So if, let's say you were using a cementitious product to build back a structure and then using a polymer product to top coat, you would want a certification letter from each of those, or at least one of those that certifies the two materials are compatible. And so you wanted to make sure you have that documentation. There's cured in place liners. These are, like I said, they're actually used for I&I removal. They're used for corrosion protection, used for restructuring of manholes. Very similar to the CIPP technology, only done vertically. Manhole, there's several technologies available out there. There are custom fit systems and there are stretchable systems out there that can be used in manholes for the putting in a cured in place type liner. There's panel liners, where generally used for non-structural lining for corrosion protection primarily. These are plastic panels that are fabricated for the shape of the manhole and then essentially glued in place and the seams welded to give it a complete monolithic installation. Again, a common system used out in many areas. I've used them in junction chambers and things of that nature where panel liners were very effective. Chimney seals, also something that, of course, addresses only a specific component of the manhole. This addresses the joint between the casting and the chimney, which is a common source of inflow during rainstorm, possibly infiltration in high groundwater tables. And so they are very commonly used to seal that area. And there are a number of different systems, anything from mechanical to a polymer to a cured in place type system. There's probably a dozen systems out there in the marketplace. You have to really take a look at which ones apply to your particular project. There's barrel joint seals, which are rubber. These are mechanical seals, very much like the chimney seals, but they are used for joint sealing the in a concrete, precast concrete type manhole. That's joint leaking. We've got bench and channel inserts, which are becoming popular, which are usually pre-manufactured out of a polymer material, so to give them longevity and good corrosion resistance. And of course, there's dish inserts, which are commonly used just below the manhole cover to catch any of the flow during a rainfall event that may come in through a manhole cover holes that are commonly drilled in the manholes. So that's a little background, quick background. I didn't want to repeat all of the guidelines that Lynn had gone through, but that gives you an idea of how to select these. It's not just a matter of listening to somebody. It's a matter of doing some research, seeing which materials are compatible, and then writing a specification. Now, the NASSCO performance specification guidelines are very similar to the CIPP ones. They are usually set up in parts 1, 2, and 3. Part 1 is the general, kind of a general specification. I won't go through the details of it. You can download this specification off the NASSCO website, and you can, of course, look at it in detail. But some things I want to maybe highlight. This chapter is a general discussion of project requirements of what the contractor is to do, perhaps what the inspector needs to do, what training might be required. One of the key things, though, I want to emphasize, and Lynn touched on it briefly, is the references. We as an industry, we have available to us a number of different agencies that produce specifications, and ASTM is a key one for our industries. The American Society of Testing Materials that produces specifications that are peer-reviewed, that become the de facto standards of the industry. And it is important as we reference these, it isn't just a matter of referencing it because every spec references them. It's a matter of actually defining what in those specifications are required in the contract. As Lynn mentioned, it's one of two ways to do that. is either reference the chapter or the section of the specifications that is included in the contract, or recopy that section right into the contract documents. You can reference the ASTM, but define it right in the contract documents that these are the requirements of the contract. Because unless that is specifically cross-referenced, a lot of times contractors will just not even pay attention to the reference specifications. So that's an important part to cross-reference in the actual documents. And of course, your warranty inspections need to be mandatory and more frequent than other technologies. And I say that only because coatings and linings, when they're installed in a manhole, if they get defective, if they start having pinholes or pinholes remain, they will start deteriorating fairly quickly. And the common thing we need to understand with coatings is if a coating is not monolithic meaning it completely covers the structure like a shell, if there is a defect or a pinhole, then the corrosive environment can get through that pinhole, can get behind the coating, and once it gets behind the coating, then it actually accelerates the deterioration of the manhole. So it's very, very important that these projects, once they're completed, they are effectively reviewed again during the warranty periods, not necessarily a year later, but perhaps 3 months to 6 months, and then again in a year, because coatings do have a propensity to have defects. And if those defects can be repaired very, very quickly, that will ensure the longevity of the coating. If they're not repaired, the coating may fail over time. So something very, very important to consider when selecting these materials. The part 2, again, not going through into the detail of each of the linings, but they're listed. You can read those. They generally include the general introduction of each of the coatings. They reference for each product. They references for each product that we just talked about that govern some of the way these products are tested and installed and verified. And repair and resurfacing material compatibilities talks about that for each of the different products. So each section will have, of the part 2, will have a section for each of these different technologies. Now, when writing a specification, remember, these are guidelines, so you would not necessarily write a specification with all these products in it. You might pick 1 or 2 of these products. So you would use the information pertaining specifically to those products to build your specification. Okay? So typically a manhole rehabilitation project, whether it's a combination of grouting and coating, build back, grouting and coating, it could be multiple technologies. They need to be specified, and you can basically get that information from these specification guidelines. Part 3, again, part 3 is the execution for each of these technologies. The execution includes general overview, the structure preparation, which of course in most cases is extremely important. Repair product, the repair product compatibility, again, important that if multiple products are used, it discusses that for each of these products, more important in some cases than others. Product execution, and then testing and inspection of each of these products. Each one will have some common inspection and testing requirements, and others will have specific testing requirements. So each technology is individually defined in the specifications, and they can be selected to prepare a specific specification. So let's talk a little bit about quality assurance, some things that the specification says. It talks about testing. It talks about typically testing 10% of the installed systems. Should be tested using a testing procedure specified. And as I said, there are different tests for different products. So for products that bond, we want to make sure we do a test that makes sure it's sticking to that existing host structure. Okay, and if we if we want to make sure, we don't have any pinholes or potential corrosion paths that could continue corroding the manholes, but we want to test it for that. And then there are other tests. So for each of the systems that are installed, there are specific processes that require quality assurance, and these are described in general in the specifications. We also recommend in the specifications a chain of custody, where the contractor can perform the tests in the presence of the owner's representative, or the owner can essentially do the testing. It's most common where an inspector will witness and be in the presence of the contractor while the test is being done, and then properly document that. So the owner's representative can at that point receive test samples from the contractor, and the test samples are usually appropriate where a product is being installed for structural rebuilding of the manhole, such as cements would be a typical example, where it's important to test actually a sample of the materials and get a test result to make sure it meets specifications. But in all cases, the owner's representative needs to maintain the chain of custody of all the samples that are transmitted and tested to verify the system's compliance. This is another thing in the specification that we typically recommend. There should be an item in the contract, which we'll talk about items a little later, but I want to mention it here, is where there's an item in the contract for paying for this testing. The testing should be through the owner's representative, should be paid by an account from the owner. It should be kept separate, and the chain of custody should always run through the owner and the owner's representative. So let's talk a little bit about testing for the different products. Of course, the visual test is one test that it really applies to all products. You want to make sure that visually you can measure visual, you can actually look at the product. However, the visual inspection needs to be done from inside the manhole. So it's not acceptable to be standing up on the surface with sunlight glaring at you and look down into a manhole and expect to be able to visually verify that the manhole has been improved properly. So visual inspection really does require an inspection from inside the manhole. Cementitious materials, the property testing is something we do. There's a standard procedure for that. It's an ASTM C109 is the designation for it. It's a 2-inch by 2-inch sample that the contractor takes. The owner's representative sends it to a lab. The lab does a compression test, a strength testing on it, and verifies that the product that the contractor is installing is meeting the specifications. And like I said, it's not a cube or something that is just handed to the inspector. It actually has to be poured from the material being installed into a mold. You can see the typical mold. You have here one with 3 spots in it, and give you an idea on the bottom right where the cube has been taken out of that, and that's used for testing. That's typically for cementitious. For vacuum testing is a test that tests the leakage coming into a manhole structure after either installation or rehabilitation. Vacuum testing was developed for new manhole installations. It was never developed for rehabilitation technologies. However, it has been adapted to be used for manhole rehabilitation, but typically the caveat is that the entire manhole needs to be rehabilitated. You can't test just a coating that may have been installed on the manhole wall or a seal that might have been installed on the chimney. It has to be an entire sealing of the entire manhole, everything, every penetration, every section of a pipe coming in. Basically, all 7 components have to be rehabilitated. Then a vacuum test generally would be valid for that type of situation. Film thickness measurements commonly are done during application, but typically only for products that do not set instantly. So for epoxies and for concrete or cement, rather, lining systems, we can do a wet film thickness measurement. There's different approaches to different products. Very common. That gives the inspector a running idea of exactly what is being applied. There's holiday detection tests. Holiday detection tests are tests that we've also termed them spark testing. It is a device that sends an electric charge through the structure, and the inspector or the contractor runs a wand. These little metal fiber hairs go across the surface, and if there's any defect or that is any coating that's too thin, that a spark will occur. When a spark occurs, that is considered a defect in the coating. Contractor then fixes that and then retests it to make sure that the installation becomes a fully monolithic installation after the project is complete. Very common in any product that's used for corrosion resistance, spark test is absolutely, or holiday detection test is absolutely necessary. Adhesion testing. Adhesion testing is a destructive test. It's a test whereby usually a minimum of 10% of the manholes are selected. And this is something the inspector would do. If he has a concern on a particular manhole, he obviously would select that manhole. And what it involves essentially is gluing a metal, what we call a dolly, which is just a small, looks like almost like a small chess piece that is glued to the coating. We use an epoxy type of glue. It's set on the wall at different locations as selected by the inspector. It's allowed to cure overnight, and then after curing 24 hours or at least overnight, then a device is used to try to pull those dollies off the coating. And the basic criteria, and it gets a little more complicated than this, there is an ASTM for this, ASTM 4541, ASTM 7234, and there's a NACE specification that you can get more information on this. But the key is we want to test to make sure that that coating has sufficiently bonded to the whole structure. Make sure that there's no ability for that to peel off because of water leaking through the wall or other water vapors coming through the wall, things of that nature. So we want to make sure it's bonded properly, and we test for that. Adhesion, okay, so that generally covers some of the testing that we do with the different products. There are other tests that we use during installation, and those are covered also in the specification, such as what the acid surface is, the pH levels, and things of that nature. We can test all of those things as well. And those are covered also as part of the preparation of the product as opposed to the installation of the different materials. But there's some sample bid items that you might want to look at is, again, mobilization, different lump sum items for vertical foot. Your typical system installation is typically a price per vertical foot. That's common in the industry. So in other words, if you have a 4-foot diameter manhole, 18 feet deep, the price would usually come in terms of so much per vertical foot of installing the product. Replacement of castings and frames and covers would be handled separately. Manhole adjustment materials, bench refill, manhole steps, if applicable. And those are all potential bid items that you might want to think about including in the contract. Okay, so I gave you a general overview without getting into all the specifics like Lynn did, but those are all included in those specification guidelines, and they are available to anybody that wants to download and use those as a basis for preparing a set of specifications. Some other ones that Ted already basically mentioned, and I'm going to cover them very, very briefly, simply because of time. We can talk about each of these and have, if you have some questions, but one of them is the Performance Specification Guideline for Pipe Condition Assessment using CCTV. So this is a specification for letting out a bid for CCTV inspection that actually will give you pipe condition assessment, which is based on the CIPP program. Again, it goes through the parts 1, 2, part 3, and 4, anything from general to special provisions that might be specific to that project, to general provisions, which is rather than specific provisions, it would be general provisions, including things like maintenance of traffic, existing utility and how they're handled, use of the premises, protection of trees, and all the things associated with property and working in a municipal environment, working in the public sector. And then Chapter 4, Part 4 would be the execution, which would talk about the general television inspection and computerized equipment and how it's used out in the field. Part 5 in this particular case goes into payment for work and how these quantities are typically measured. So there are some standards that are set out in terms of how to do this. Through a pipe cleaning guideline specification, this is similar again. It's for cleaning for cleaning pipelines. Now, all of these specifications, by the way, these have been prepared by NASSCO representatives, NASSCO committee people that are involved in the different active committees. They all go through peer review from contractors to engineers to municipal people have a chance to look at these. So all of these have been prepared with that in mind. But your sewer cleaning specification, again, has several portions to it. You've got your general, you've got your special provisions and things of that nature. And again, they're similar from contract to contract. You've got your general provisions and you've got your execution. And so all of these are pretty much consistent that way. Here's an interesting one that is more of a tool. It is a pressure pipe guideline matrix for selection of pressure pipe assessment technologies. This was prepared by the NASSCO Pressure Pipe Committee, and it goes into all the different technologies that are used out there to assess pressure pipes for leakage, for deterioration, for pipe wall thickness, and so on. And it's a pretty good document. It was put together by a number of professionals, like I said, from the Pressure Pipe Committee, and it gives you some successes and things that happened when these processes were used and what data was collected as a result of that. So it's a good tool. It's not a written specification, but it's a tool to get you started with a pressure pipe project that you're perhaps writing a spec for. The smoke testing, something that was produced last few years. It's a guideline, again, guideline specification and data dictionary, which describes a lot of the terms used in smoke testing. Again, general background includes scope, requirements, personal data, and so on and so forth, personnel qualifications. Part 2 would be equipment, the type of equipment that would be used with smoke testing, blowers, smoke production, etc. Installation, again, how the work should progress, how to schedule it, and of course it'll go into notifying homeowners and things of that nature. So in the event smoke gets into a home, what to do, and what information should be provided in the event that happens. So these are all things that are included in these specifications. There's a pipe bursting gravity sewer main spec, which is specifically designed for high-density polyethylene, which is probably one of the most common pipe materials that are used in the pipe bursting industry. There are other products that are used. There's PVC, there's ductile iron pipe, there's fiberglass reinforced pipe that are specially designed with a restrained joint, low-profile restrained joint that are used for pipe bursting. But this particular specification is specific to high-density polyethylene pipe. And again, it goes through the general qualifications, the scope, then the materials, and in this particular case, it focuses on the HDPE, how the pipes are put together, how the connections should be addressed, and the material used for sealing at the manhole. It talks about equipment, and it talks about the execution of the project. So it basically gives you the soup to nuts of how to prepare a specification for the pipe bursting technology specific to high-density polyethylene. There's a folded pipe guideline for pipe that is manufactured in the factory, then mechanically deformed, and then reformed in the field. A little different than the CIPP in the sense that it's not manufactured in the field or produced in the field. It's actually produced in the factory and then processed in the field. Again, describes the description, the references associated, and there's many ASTMs on this particular type technology, the performance work statement requirements, quality controls, and so on. Part 2, again, is the pipe material, structural requirements, minimal physical properties. It basically defines what's out there in the industry. Installation criteria, of course, how they're installed, what they should look like when they're finished, how the services are reconnected, and so on. Basically, again, a total guideline for a folded type technology. There is a standard, a suggested standard specification for pressure testing and grouting. And this is used in many cases. This is a product that's used in advance of either by itself or in advance of other products. But again, it covers the general requirements with the pressure testing and grouting. It goes into the different products and the testing equipment and the grouting equipment and the chemical additives that are added to the grout. It's a basically pretty comprehensive guideline for how to grout and pressure test a pipeline. Execution, all the control tests. How do you know what's going on? How do you know how much grout is going in? How the pipes should be prepared? The roots and loose debris and how they will affect the installation, and how the grouts are prepared. These are just a whole list of things that describe what an inspector on the job site would look for, how they would test the grout, and how would they verify how much grout is actually being installed, and is it sufficient. So, in summary, lots of opportunities for writing specifications, lots of guidelines, and more will be coming. So in addition to other industry standards, NASSCO provides the performance specifications, and we do focus on performance specification guidelines. They're written by industry professionals, and I suspect over the next year or two, there'll be more coming out of the committees. What I always tell people is if you want to get a spec out there, get on a committee and make it happen. With that, I think we're into questions. So I'll answer any questions. Ted?
Thanks, Jerry. And I guess I would just say we've gotten a lot of questions. I'm going to try to jump right to it. One we just had recently was, are there any specifications any other specifications that are available on the NASSCO site. And I know everything that you just put out, Jerry, is actually available on the NASSCO site. If you go to the home page under the Publications and Specifications tab, you can find pretty much all of the references that Jerry mentioned. So we hope that you're going to use that. That's not just available to NASSCO members, because NASSCO really serves the industry, not so much the members. So that's what we're here for. I want to go back.
The other thing I want to add to that quickly is there are thousands of other specs up on the website as well that are manufacturers or member specs that are also very good, but they usually are specific to a technology. But they are also very effective.
Right, and actually all our members have those specifications on our website as well, so you can find manufacturer specifications there too. Yeah, good point, Jerry. Going back a little bit on the performance specifications, there was a question about pre-qualification of contractors. Should contractors be qualified, and is that something that's generally done in a performance spec?
The performance specifications can be written in such the key with the performance specifications is to raise the level of quality and let the contractor provide the means and methods of how to achieve that quality. And of course, the other part of the performance specification that's very important is that the quality, not only, anything that's called to be measured in the contract needs to be measured, needs to be inspected, it needs to be observed, and it needs to be recorded. And if the specification doesn't follow through with the field verification of these things, of course, it's not going to work properly. But that's the whole thing with performance specifications. Now, as far as pre-qualifications, there are many, many cities that do that now. Many consulting engineers do that. I send out sample pre-qualifications to engineers all the time and give them some guidance on how they should structure that. And by the way, as a resource, you go up on the internet, there's probably a dozen municipal type qualification proposals up there that you could use just as a starting point. And so it is common today, not used everywhere, but it is used in many parts of the country.
All right. Okay, next question, and I'm going to ask these two questions that kind of go together, but the question was, who certifies the QC inspector? And I know we talked about NASSCO's ITCP program, but there's others. Do you recommend third-party inspectors? This kind of goes along with it for some of the larger projects, and should the owner's representative have ITCP, NACE, NACE, or SSPC type certification? Can you comment on that?
Yeah, I think all of those are great. I think it depends on how critical the process is. The NASSCO ITCP training is intended to give the inspector running knowledge of the different testing requirements that are typically done, how they're done. They need to be done in a certain way, and that's what the training includes. The training itself is well, it's a good basic inspector level training for rehabilitation technologies. You can step up to a NACE type training, which is more intense. It's a longer training period. It gets into actually doing some of the tests and the performance of the tests. By the way, the NACE inspector, the independent third-party inspectors, they are available. You can pretty much go up on a website and look in your area and who is a NACE and certified inspector. And putting a third-party inspector on a job site is, quite frankly, is the next step up above a having a typical inspector training.
Okay. Are there different warranty durations recommended for coating materials versus liners?
Not so much the length of the warranty. Warranties are typically recommended. The warranty should not be longer than what can be insured by an insurance company. Okay, typically that's the guideline. If an insurance company will insure it then you have a fallback position as far as the warranty is concerned. I think warranty inspections, to me, would be more important when you get to coatings. So if, let's say you had a warranty, let's say 2-year warranty on a coating, I would recommend much more frequent inspections. I would recommend, for instance, 3 months to 6 months that a representative section of the project be inspected. The key with coatings is, and I've learned this working for on federal projects. The general industry recognizes that perfection is not always possible. So there's always, or not always, but there's always a possibility of a defect remaining in the completed project. That defect needs to be discovered fairly quickly, and it needs to be repaired. And once it's repaired, then the coating should have the longevity desired. If it's not determined, and that defect begins to permeate over time, over years and multiple years, it will cause the failure of the entire coating system. So inspection is more important, not so much the warranty period, but the inspection during the warranty.
Okay. A question that really applied to one of your slides that talked about how much of the system gets tested. Typically, you test 10% of the system, and then you said if 5% of the tested system fails, then there's more testing. Now, did you mean 5% of that 10% or 5%
Yes.
of the entire system?
No, 5% of the 10%, and then, of course, that continues. As that 10% is tested and more than 5% of that fails, then you select additional areas to test.
So it's actually 5% of the system that would fail.
Right.
Okay.
Well, no, it would be of the testing that was performed. You would, if 5% of that fails, then you continue. Then you continue testing. In other words, what you're achieving in that 10%, you'd like to get 100% passing if at all possible. But if you get a 5% failure, then you continue selecting additional areas.
Mm-hmm. Okay. Okay. For manholes, can you comment on different projects for lining manholes if the manhole is subject to a corrosive environment like H2S?
Well, it depends on the level and the parts per million of the H2S and the corrosion, but typically what happens is you go to a polymer type product. You go to an epoxy, there's polyurethanes, there's ureas, there's curative place liners, all the plastic liners that are a plastic component. I would probably look at as a potential for a corrosion type barrier. In many cases, I've used that in combination with other technologies. Even the cements, the calcium aluminates, have a fairly good corrosion resistance. However, it's all a matter of degree and level. When you get into extreme corrosion environments, then the polymers or the plastic materials would be preferred.
Mm-hmm. Okay. Yeah, that's about all the time we have for questions. Now, I want to take a moment to thank our speakers, but to thank our sponsors for making this webcast possible. So as promised, I want to take this opportunity to learn some more about them. Our first sponsor is Parson Environmental. Parson Environmental has been serving our industry for about the past 30 years. It's my pleasure to introduce the representative from Parson Environmental, Craig Gall. Craig?
Thanks, Ted. Good afternoon, everyone. As Ted said, my name is Craig Gall. I'm the president of Parson Environmental Products. We have been in business since 1985, and our goal was to try to bring some quality and innovative products and customer service with that to the manhole rehabilitation market. As a result, today we have the most comprehensive line of products in the industry. Throughout the 30 years in business, we've always tried to treat our customers with the utmost respect and only make promises we expect to keep. Our first product was the Parson manhole insert, which are pictured. You can see that up there. They're basically used to stop surface water inflow, which is the first I from entering through the manhole cover and ultimately into the wastewater treatment plant. Treatment costs for that clean water can cost hundreds of thousands of dollars annually. Installing manhole inserts directly under the cover is the easiest, most cost-effective way to dramatically reduce inflow and substantially lower those costs. As you can see, we offer both HDPE plastic and the stainless steel models, plus the model on the right, which eliminates odors from manholes in residential areas. Stopping groundwater infiltration is a necessary process when tightening up your manholes. Parson Quick Plug is an easy-to-use, fast-set hydraulic cement that mixes with water and has a set time of about 1 minute. It's capable of stopping small to medium-sized leaks. Okay, next slide. For higher volume leaks, we recommend the use of our urethane grouts. Parson Seal Tight is a hydrophobic urethane, which means it does not need water to react, and is dispensed from a dual caulk gun through a static mixer. It has an initial reaction time of about 5 seconds and can stop active leaks up to 50 gallons per minute. Parson Hydro Grout is also a hydrophobic, and Permaseal is a hydrophilic grout, which means it needs water to react, are injected through the manhole wall in the area of the leak using injection ports and pumping equipment. Some rehabilitation projects could require repairs to the manhole bench and invert. The repair products need to be easy to apply and set up quickly. Parson RPM is a cementitious product that mixes with water and has a set time of about 30 minutes. It can be used for repairing the invert or patching the bench, as well as other areas in the manhole. Parson Epoxy FS1 is an epoxy coating that is 100% solids, can be brushed onto the invert or bench, and has a set time of about 45 minutes. By far the best and most cost-effective means of providing structural integrity to either old, poorly constructed, or deteriorated manholes is with the application of a high-strength cementitious lining. As you can see, Parson offers a complete line of these products that can be hand-applied, gun-sprayed, or spin-cast in place. Parson MH Liner is a Portland cement-based microsilica-enhanced fiber-reinforced product that can be applied up to 3 inches thick per coat. Parson CA Liner 100 is a calcium luminate cement-based lining product used for lower pH, higher corrosive environments. Parson CA Liner 100 Plus provides an even higher level of protection, and Conblock MIC is a liquid additive used with either MH Liner or CA Liner 100 to eliminate microbial-induced corrosion, or MIC, which is the primary cause of deterioration in manholes. All of our cementitious products provide significant structural integrity to the existing manhole. Parson Epoxy SCL80 is a high-build, 100% solids epoxy coating used to achieve a high level of corrosion protection, which could be in the area of a pH of less than 1. The product can be brush or spray applied up to 80 mils thick in a single coat. Parson Epoxy SCL80 HB is an ultra-high build, 100% solids epoxy coating with application thicknesses that can reach 125 mils or 1/8 of an inch per coat. It can also be brush or spray applied. Our composite liner system provides both structural integrity and corrosion protection by combining one of our cementitious materials with our epoxy coating in a unique same-day application. Parson provides both a hand-applied and a mechanical chimney seal. The Parson Epoxy FP is a brush-on flexible epoxy urethane hybrid coating that is packaged in pre-measured kits. FlexRib seals are manufactured from EPDM rubber and are installed using 2 stainless steel bands that are locked in place with a specialized insulation tool. We also offer lightweight, compact, cost-effective application equipment for all of our rehabilitation products. Our Pro 50 Starter is a portable, all-electric equipment package that is capable of gun spraying or spin casting any of our cementitious linings. Our epoxy application equipment is used to spray or spin cast Parson Epoxy SCL80 using a hot pot system. The grout pump is electric and used to inject Parson Hydrogrout and Permaseal. Sorry I had those slides mixed up. They were back to the chimney seal. We also offer several accessory items for inserts. On the left, you see a manhole cover cushion, which can quickly and easily silence noisy, rattling manhole covers. We have steps. We have a couple different kinds of manhole cover removal tools. Also volumetric mirrors for measuring flows, and paving risers for raising manhole covers without having to remove the casting from the road. All of us at Parson Environmental Products sincerely appreciate the time you spent with us today, and we look forward to helping you ensure the successful completion of your next manhole rehabilitation project. Please feel free to visit our website at www.parsonenvironmental.com or give us a call at 1-800-356-9023. Thanks again for your time. Back to you, Ted.
Okay, thanks, Craig. Our next sponsor is Avanti, and they've been a strong supporter of NASSCO for many years. They've actually been serving the industry for 36 years. And it's my pleasure to introduce my friend Don Rigby. Don?
Thank you very much, Ted. There we go. Yeah, pleased to be part of this presentation and associated with everything that NASSCO stands for. One thing that Avanti stands for is defeating infiltration. And Avanti is a manufacturer and producer of injection grouts, but we're primarily a service organization. And education is how we choose to go to market. I could talk for hours about this, but there's really only about 3 things I'd like to accomplish today in this few minutes. One is the fact that CIPP lining and injection grouting are complementary technologies versus competing alternatives, and that the root cause of the demise of our collection system is, in fact, infiltration, and that to defeat infiltration, a comprehensive, holistic approach is required. Now, if I'm singing to the choir when I talk about the consequences of infiltration, I apologize, but I think it's important to cover the fact, first and foremost, that infiltration is directly related to sanitary sewer overflows, and that sinkholes are the result of lack of maintenance in the underground infrastructure. And infiltration reduces the lifespan of our underground assets. Because of the infiltration, soil fines are ushered into our system, reducing pipe capacity. And basement backups, they're a PR problem for well-intending utilities. And finally, the increased cost associated with infiltration is absorbed by the ratepayer. Every day I wake up grateful that these rehab technologies exist, and these all have one thing in common. They are structural repairs. Injection grouting is not structural. And if the problem is infiltration, grouting is an engineered process specifically intended to stop infiltration. So what is infiltration? Or what is injection grouting? It is a liquid resin that turns into an impermeable solid in a predictable time frame used to stop leaks in above-grade structures, stop infiltration in below-grade structures, stabilize soil, control groundwater, and seal annular space between hose pipes and liner. 3 primary grout families. Acrylic grouts are typically associated with non-man entry systems, and main lines come to mind, and the reason for that is it's typically injected through a remote packer. And that remote packer relies on the fact that the low viscosity of acrylics, equal to that of water, It manages that it actually injects out through the defect into the soil. Urethane grouts are thicker viscosity, and because of their flexible quality, they're often used in manholes. Cementitious grouts are often in geotechnical applications such as tunnels and mining. Let's go to the target environment. And our underground systems are complex, and there's dozens of opportunities for I&I to occur. And what complicates matters is that the sanitary system rests below the stormwater system. Rain events occur, storm systems experiences a surge, exfiltration occurs, water does what it does best, it follows the path of least resistance, and it settles in the sanitary trench. The groundwater will find its way in. And there's 4 points of entry: manholes, mainline joints, service line connections, and certainly the first few feet of the lateral. And here's how and why it works. Solution grouts are injected through the defect to the outside of the pipe to form an impermeable gel soil matrix. So the grout inside the joint itself is immaterial. Up to 70% of infiltration enters the system from laterals and lateral connections. And injecting a mainline pipe that's already been CIPP lined, grouting seals that annular space between liner and host pipe. So let's get specific. Sullivan's Island recently completed a grouting project. They elected to grout first because 90% of their problems was infiltration. Their next step is to go to CIPP. But prior to grouting, they chose to spend a couple years sealing their manholes. And the reason for that is they knew that the water table would rise. And sure enough, they now have a new problem. After a rain event, they have standing water that typically would have been washed away through I&I and onto the wastewater treatment plant. Naperville had no choice but to grout first before doing a lining project. The volume of infiltration was too great, so they grouted both laterals and main lines so that CIPP could be installed correctly. Granite City had a different problem. They're sitting at the confluence of 3 major river streams. Spring floods come every single year, and the result, sinkholes throughout the city. With large diameter combined sewer system, lining was cost prohibitive. Grouting was cost effective. And since that project in the last 5 years, no new sinkholes. Downers Grove targeted 15 of the most problematic basins with a comprehensive grouting program. And the net effect, 21% reduction in infiltration system-wide. And the $3 million project saved $30 million in collection system improvements. The 5th largest sewer district in the nation has been self-performing grouting for 25 years and have 25 years of very, very detailed data collection to validate a reduction of flow to 3 regional treatment facilities of 128 million gallons per day. And they absolutely know for every dollar that they invest in I&I earns $2.50 in cost avoidance. These are some of the reasons why grouting has enjoyed a resurgence from the engineering community. Grouting's had a 50-year history, but in the last 10 years, ASTM standards have been introduced for main lines, laterals, and manholes. And in the last 3 years, NASSCO and ICGA released operating standards that's unified the contracting municipality and engineers with more predictable results. After a 10-year study and 20 years of validation, the U.S. Department of Energy states the half-year life of AV100 is 362 years. It's not temporary. It's permanent, which is why engineers, contractors, and municipalities agree grouting and lining are complementary. technologies versus competing alternatives. And why grouting, grout first to stop infiltration, line second for structural repair, and do both when necessary is sound strategy. And if you agree infiltration is destroying our collection system, make certain your I&I program targets all 4 points of vulnerability. To continue the learning, you're going to receive 2 of these documents supporting the business case for why to and how to engage grouting in your rehabilitation programs. To stop leaks, stabilize soil, and control groundwater, you're encouraged to visit avantigrout.com. It's an educational website to view animations, case histories, and technical data. And with that, I'll say thank you. And speaking for all of Avanti, we look forward to helping you move your projects forward.
Hey, thanks, Don. Just to kind of close, I want to just mention that NASSCO really is proud to have Parson Environmental and Avanti as members, and we're proud of the work that they do for this industry. We appreciate their support for this webcast and their support for NASSCO. I want to thank the speakers, Jerry and Lynn, who continue to give their time and vast experience to support the trenchless industry. And finally, I want to thank all of you who participated in this webcast. I want to encourage you all to get involved in organizations like WEF, like NASSCO, like ASCE, and also it's important to get to some of the trade shows like ASCE Pipelines in Baltimore at the end of August or WEFTech in Chicago. You can really see some of those latest rehab technologies. Thanks again for participating, and we'll see you at the trade shows.